Welcome to the AI innovation space. We are your experts, and I'm Iyanu.
And I'm Todd.
We're here to offer our unique insights and hold conversations with top leading innovators in the world of AI and machine learning.
We dissect and discuss the often complex realm of AI in an accessible way and go deep in discussing the innovative technologies that impact our lives every day.
This podcast is sponsored by Lumen, an IT contractor offering a creative and human-centric approach to medical imaging, cybersecurity solutions, training and support, and more. Illumin's values of ingenuity and connection make us a leader in adopting innovative technologies for federal healthcare and beyond.
Visit Illumin's website at www.illumin.com for an overview of the services offered and to read our blog series on leveraging AI for your business. Thank you so much for listening, and let's begin.
All right, welcome to another edition of the AI Innovation Space. I have my co-host with me, Todd. Todd, how you doing?
Well, thanks, Yano. Looking forward to another episode today.
I am too. And we have our guest here, Clark. He's a senior staff data scientist, has quite a lot of experience working with UW and some experience with Epic systems and really amazing background in artificial intelligence. So welcome, Clark Shu. Nice to have you on.
Thank you for having me.
Excellent. So we're going to dive deep. I'm going to sort of pass it on to Todd, or I could take it on from here. Todd, how do you suggest we go about this?
I think we could hear from Clark on some of his background, some roles he's had that kind of led him to the machine learning and artificial intelligence space. Maybe you can kind of fill in how you got involved in that space, Clark.
Mm-hmm. So in terms of my current work, I work closely with clinicians in government space to develop machine learning and artificial intelligence out of electronic health records and other systems such as patient archival communications, lab systems, and so on. And some of the background that led to my current work was, first of all, working as a data analyst. So my first experience in data was with a group called the Institute of Clinical and Translational Research. And the idea was within healthcare, there's a step between the data storage and making the data valuable. So dissemination and translation are the primary components for making that happen in a research setting. In addition to that, I also have application development experience as a solutions engineer at Epic. And that was where I worked on developing electronic health records and creating the systems and doing some ML and AI powered feature build within the application layer itself as well.
Very cool. Very cool. So what basically drove you into machine learning? What piqued your interests? How did this start?
I would say first, I was very interested in the types of problems that we're solving in healthcare. So traditionally, there would be rules engine or a lot of hard coding and deterministic systems in order to route information, provide patient care, give information and visibility to frontline workers such as nurses and doctors, and also operations managers. Feel that with machine learning, artificial intelligence, we're able to make difficult problems easier to solve, and things that were previously considered impossible or impractical, bringing it within the realm of possibility. And some of the major shifts in the past few years, one, I've seen a lot of work on machine learning as code. So as I mentioned before, whereas traditionally we might have a rule engine with thousands of rules execution plus rule chaining, forward and backward chaining, all of that might be replaced with a single machine learning algorithm and thus drastically reducing the size of the code. In the example, for example, Google, they used to have a lot of rules running in their search engine, and the PageRank algorithm was a lightweight way to reduce the size of that code source drastically. So machine learning as code is definitely a very important paradigm from bringing in machine learning, artificial intelligence to systems and application engineering. Another one is being able to do decision science. So enabling leaders and other people from across healthcare to be able to make decisions in real time and really make that based on data, so data-driven decision making. In terms of the decision science, being able to structure reports and make forecasts and predictions out of machine learning was not only, in some cases, better performance than what human analysts could do with forecasting other types of models, but it was also very maintainable and would continually update based on the data that was coming in. So that's the second area where there's been a lot of growth. And a third one has been the explosion of domains that were previously thought impossible. So for example, computer vision, being able to detect objects, classify objects in images, that has made a lot of strides in the past 10 years. Some of it has been on the infrastructure. So for example, neural networks have been around since the 70s, but they only recently became very powerful in the past 10 or 20 years because we have this infrastructure to be able to scale. And some of the results from Google, for example, show that algorithms, the choice of algorithm might not matter as much in some computer vision applications as the size of the data that you're putting in. So hand in hand with the rise of cloud infrastructure and bringing a lot of these heavyweight infrastructure to the hands of small, medium businesses, smaller groups, has really done a lot to democratize this type of AI and machine learning development for use cases such as computer vision that has been previously very difficult. And another one that is in the news a lot is also LLMs. So large language models such as OPT, Google Bard, ChatGPT. This is similar. It's been democratized a lot through the service of SaaS-based APIs and pay-per-use or on-demand, and being able to provide natural language processing, natural language generation, natural language understanding capabilities to domains that were previously thought to be difficult, or even in like the general intelligence or generative AI space that researchers 10 or 20 years ago were just dreaming of.
Sure, thanks. That was excellent analysis, Clark, on some of the topics that's going on with machine learning. One thing that I think would be interesting for our audience to hear about is kind of the applications that you're working at with Epic. Like you were working there with their EHR system. What were they trying to accomplish by bringing in machine learning or AI into that?
So some history about Epic for viewers that might not be familiar. They're one of the electronic health records providers. They actually provide EHRs for over half of the population in the United States. The other major players include Cerner, which was acquired by Oracle, and Cerner is very big for the VA and other large government institutions, as well as for smaller clinics. Instead of Cerner or Epic, some groups might choose Allscripts or Athena Health or GE. Some of so those are around like the top 5 main competitors in this space that have like over 80% of the market share in EHRs. In terms of Epic itself, it started in the 70s, and the CEO likes to say that she started in the basement and got it working that way, a little bit like a Microsoft type story. And at the time, they were actually, it was before SQL became very popular. So they created their backend on a utility that was created by Massachusetts General Hospital, or MassGen, called MUMPS or M. So their backend was actually a NoSQL key value store on M. And since then, they developed on Visual Basic and into modern frameworks such as TypeScript and Node.js for applications such as, let's say, Patient Web Portal, which is a website where you can log in to MyChart, and then also a suite of mobile apps such as App Orchard for tablet, phone, and I think even iPods and other smart devices, and also smartwatches. So in terms of the goal for machine learning, there are about 2 or 3 main prongs. One of them was source code reduction and also improved capabilities. So some of the earliest efforts in machine learning in this area were, for example, simple visit coding. So the idea is in hospital coding, a human analyst will read the chart and drop, let's say, ICD, NDC, or other code sets for that claim to go out to billing for reimbursement for the provider. So simple visit coding, Epic was able to run machine learning components to automatically drop codes on the chart and send that out for, as the name suggests, visits that had only a few number of codes or were relatively simple to complete. This freed up analysts and hospital coder time to focus on the more complex cases that might border in the 500,000 millions of dollars and involve like 50 or hundreds of code sets. So by having thousands of charts with only 1 or 2 codes closed, it really opened up the space for coders to focus on the complex cases that AI couldn't handle and improve the claims quality, reduce number of claims rejections, improve claims processing time, and overall improve healthcare delivery and support for the industry as a whole. Another area that has been really important with ML AI is the idea of edge computing and IoT. So I mentioned earlier that there are integrations with smartwatches, iPhones, tablets, and so on. So actually a lot of hospitals, they take advantage of the edge compute available in devices such as smartphones and tablets. And they actually have, for example, nurses and doctors, when they do the rounds, they have a version of Epic running on their tablet, and they can enter chart info or access chart info on the go without having to carry around a very large station that has a whole computer on it. Similarly for Fitbit, and this goes a bit past my time at Epic and into UW, which also used Epic, so there were some integrations there. But we had a researcher that was leading in the heart area, and the focus that we did there was a collaboration with Google to integrate Google Fitbit data with my chart at Epic. And the idea here was we could run machine learning on the edge on the Apple Watch and predict the healthiness and also give recommendations to the patients who opted into this process for improving their health. So I think this also borders on some of the really important ethical and social questions as well, which is who uses these AI algorithms, who benefits, and what are the processes for consenting, opting out, and also managing your own data. So in that research study that I talked about with Google Fitbit, the patients who were in the study, they all explicitly opted in and signed a research consent. But we could imagine maybe 10 or 20 years from now, maybe this feature will be out of the box. Are people really comfortable with tracking their heart rate when they buy a Fitbit from the Apple Store? I think these are some of the key questions that we have to tackle in AI going forward.
That's pretty cool. Thanks so much, Clark, for sharing that. I'm very curious, about, and this is a task that leads to a majority of the things that we do with AI and ML, the ETL process, at your, if you're able to share at your job at Epic Systems, and how you were able to, bring those data sets together and started to perform the operations, the ETL operations on them. And if you were going to apply AI ML to those, what would that look like?
Mm-hmm. So I think this brings up 2 important points. One is that, as we mentioned, these AI algorithms typically require a lot of data. And there's very often a dependency with the closely allied art of data engineering, which is all about moving data around between systems and processing it. You mentioned ETL, so that stands for process in tech, which we call extract, transform, and load. And so these are, at a high level architectural point of view, the key steps in which we take data out of a system. We, while we're processing it, make it in a format that can go into the target system. So it's all about, we have source and target systems, and we have ETLs between them to, from a diagram perspective, draw that arrow, and from a practical perspective, get that data into where we need it to be to run these algorithms, or even just support traditional workflows. So there's both data engineering in the traditional sense, and also data engineering that goes to supporting the ML AI algorithms. And more commonly, that second role is called machine learning engineering, which is one of those spaces where the machine learning engineer both handles the data engineering and the data science portions in order to get that model working. So in terms of Epic, we had a lot of clients and hospital systems with their own backend implementations. And this goes back to our discussion earlier in this podcast where Epic used mumps, which was a NoSQL key value store. So I would actually write cache scripts to ETL the data into a relational database. And so there was definitely a lot of core software engineering and some very traditional types of issues to work with. For example, race to the bottom or record lock conditions, those were really important. So when you extract data and you query a certain master file, you're going to lock that record so that you have the state of the record and it doesn't change while you're reading it. Now, if you have multiple processes running concurrently in parallel, or just lots of different ways the record is being called, you might create a set of locking conditions that basically creates a traffic jam on that record. So you have to be very careful with these types of very low-level programming. These were very common in the 60s and 70s and early days of computing. And anytime we work with NoSQL and really peel back the layers of defensive programming, improvements in software engineering over the years, it can be a jungle of very interesting concepts that it requires someone who is very fundamentally strong in software engineering to handle it adeptly.
So how did your experience, Clark, with ETL compare at Epic to that at the University of Wisconsin-Madison? Like the process of extracting the data that you needed to build the algorithms?
I would say the primary difference was on the requirements side, both in terms of the size of the data that we're working with, the latency, which is how fresh the data needs to be, and also the privacy and security requirements around it. So at Epic, it was all enterprise grade. So we're talking about essentially whole electronic health records, maybe 50 million or above patients and encounters. And then also the latency would be defined by the product. So there were some products that ran in real time, others that had a 1-day latency and so on. And then finally, with the privacy and security, the business associate agreement was between two entities that were able to process PHI. So PHI to PHI wasn't so much an issue in terms of the privacy and security, but making sure that was secure as a whole was definitely important consideration. And taking a step back for listeners, so PHI is protected health information, and this is a type of data classifications that was defined by a government legislation in 1996 called HIPAA, or the Health Information Portability and Accountability Act. And it was updated in high tech in 2008 under the Obama administration to really revitalize healthcare. So this goes back to very high level. Around the early 2000s, we saw that the United States had the lowest health outcomes out of all the OECD nations, even though it had the highest health spending per capita. And a lot of important leaders, Obama and also Bush administration in that time, really wanted to tackle this issue. And so they saw bringing healthcare tech, in particular modernization at the application level, not even reporting or machine learning, which definitely at this point in time is a focus, as part of reducing that cost and improving outcomes. So those are the legislations, and associated with that, there are a lot of key ethical questions about managing protected health information. So coming back to the ETL question with PHI, at UW, according to HIPAA, there was the PHI designation. There's also a limited data set, which is between full PHI and no health information, and then also de-identified and public information. So there's 4 data classifications. And at the university, because not all of the business associates where the data was going from source to target had the same PHI classification, we had to do certain types of data enrichment to turn lower grade data into higher grade, as well as data de-identification to turn higher grade into lower grade data. So that was a key component that wasn't at Epic because all the BAs there were PHI to PHI. That was a very important component of the data processing within the UW academic research environment.
Got it. Got it. Thank you so much for sharing that. I wanted to, shift, gears a bit and just get into healthcare in general, and just get into some discussions around AI in healthcare in general. So, in your opinion, and how do you think about AI in healthcare? I know there are really different aspects of it. Some people are looking at it from an ethical standpoint, ethical AI and things of that nature. Some folks, look at it more from, general classification problem. Does this exist or doesn't, this exist? While there are others that are looking at it from with regards to for example, rare diseases, for example, where you don't necessarily have access to these data sets. How do you view AI for healthcare, where it is right now?
Mhm. So I primarily view AI in general as a tool in order to improve processes and perform different functions, going back to making impossible things possible and hard things easier. And healthcare AI in particular, I see it as a uniquely important tool that's able to tackle really deep social issues with healthcare delivery, provisioning, and the state of the art within healthcare itself. And so healthcare AI, I think there's a lot of opportunities to take it in those many different directions, as you pointed out. So for example, being able to do rare disease classification, like let's say some botanist takes images of a bunch of plants in the rainforest, and we can have AI help them sort through that. Or for example, working on patient care and helping doctors triage patients from the emergency department, or being able to even do drug discovery. So if you've heard of Stockfish, which was an engine used for chess, and then AlphaGo, which was an engine used for playing Go, a version of AlphaGo, which was AlphaFold, was actually able to find new protein configurations using the same neural network deep learning training over PubChem and related pathway annotation and gene set algorithms. So you can even have AI perform this bench science, as I would describe it. So the way that I see it, just given all this diversity and all opportunity, is in terms of prioritizing in terms of social impact and reducing costs and delivering value to our stakeholders. So with any AI algorithm, we have to define what we're trying to do, who we're trying to benefit, and how we're going to do that. So I always ask myself these three questions when I try to tackle an AI healthcare problem. So I can give an example. One of the projects that I did was during COVID, we created a database called PAGER-CoV, which was pathways, annotations, and gene sets. And the idea was first, who was going to benefit? We were going to help research teams look for PAGs and essentially find ways to have activations on the COVID virus and either change its effects or try to develop a vaccine for it. And then how are we going to do that? So we read in all this data from different sources, such as PubChem, National Library of Medicine, and NIH, and provided this search engine so that researchers could type in the PAGs and find this information. And then finally, what were we trying to accomplish? So at the end of the day, we're trying to accelerate research. So when COVID came out, it was this pandemic that took the world by surprise, and we didn't really know much about it for all the impact that it had. So the fact that we're able to develop vaccines and treatments and really get a handle on this within a rapid period of time really shows advances in modern medicine, as opposed to, let's say, the influenza pandemic of 1918. There's just been so much advances in germ theory, care data, that it's a very interesting time to be a healthcare IT professional. And I think is also something we can all be very proud of, that we're able to contribute in a positive way.
Excellent, thank you. Can you speak to some of the modeling and the tooling that you were using for or you would envision someone using if they're trying to build machine learning or AI models in the healthcare space?
Yes. So just to continue on from the previous question, the PAGER-CoV algorithm, we used a ranking algorithm. We discussed PageRank earlier on Google. This one used a ranking algorithm called normalized correlation coefficient, or NCOCO, and essentially returned the query terms that were most relevant to the search. And so we have this algorithm, NCOCO. It was implemented in Java, and then we had an Oracle backend storing the data. And then finally, we had a Bootstrap interface that was serving the web. So just like with traditional software engineering, there's generally you have a front-end interface or something that the user interacts with, a component which runs the model, and then finally a backend that stores the data and moves data around with those source and target ETLs, and also the data storage in normalized and denormalized format. So those are the general components to get an AI algorithm working. And there have been certain efforts to make that more accessible or more democratized for teams that don't have the ability to handle all those pieces. So one example is on some of the largest cloud providers, for example, let's say Amazon Web Services or AWS, they will offer cloud compute and storage. So instead of implementing the backend yourself, you can have that managed cloud service do that piece for you. And a step from there, there's also on AWS a machine learning managed service called SageMaker, which will often help automate or simplify a lot of the machine learning tasks as well. And you can also host your website on AWS. So you could actually just be an AWS shop and do all three components there. Something similar on GCP as well. They have buckets and instances that you can use to store on Google Cloud Storage. And then you can also write your ETLs and do your data processing on Dataproc, Dataflow, and also serve your website on GCP. It's not as easy as AWS, but you could do that as well. And then they also have AI Brain, and some of the leading algorithms like AlphaGo are available on GCP. And similarly for Microsoft, there's a bit of an arms race. Microsoft owning OpenAI has ChatGPT available on their Azure platform as well. So definitely there's some differences between cloud providers, but at a high level, there's when people talk about the cloud, having a large company like Google, Amazon, Microsoft providing their services makes it a lot more accessible for smaller businesses and individuals to be able to run machine learning on their workflows.
It's awesome. Thank you so much for sharing that. I was going to move to the next topic, which is really some discussions around some of your past success stories with machine learning and, some of the things that you've done in this space that you're really, really proud of. You want to share?
Yes. So we talked earlier about the project with PAGER-CoV. That one I'm really proud of because we quickly developed some data sets that were useful and were able to help vaccine development, and we were cited by several researchers that eventually did develop vaccines for COVID. Another one related in this space was when it first started, we really didn't have any handle on this. So I worked with the UW chief epidemiologist and other individuals in the public health department in order to work with CDC, state of Wisconsin, Dane County Public Health to do COVID contact tracing. So we quickly built a data source, and then we put a Tableau dashboard in front of the stakeholders so that people could see how many admits to ED were coming for COVID, and then also get contact tracing. And over time, we iterated over that dashboard and created a lot of good analytical tools for stakeholders to make decisions. And actually, my transition from data analytics to data science was during this time when I helped create that COVID dashboard for UW epidemiology, and then I also published PAGER-CoV for PAGs and helping vaccine research. After that, I worked on a project now that COVID faded a little bit. A lot of the traditional large-scale health problems resurfaced as research interests. So for example, Alzheimer's, diabetes, elderly falls risk. And one of the ones that I worked on was emergency department triage. So traditionally, some of the tasks that have been tackled in this space include sepsis detection and also respiratory incidents. What these all have in common is first, there's a very high incidence of these conditions. So it's very important to triage. And also they can progress very quickly. So if a nurse walks away for an hour or so, there could be an adverse event that seriously affects the patient. So having machine learning that can monitor patients in the background and throw out alerts is extremely valuable. So that's why there have been a lot of tools in this area. There haven't been as many emergency department tools for less urgent conditions. So the one that I worked on was spinal cord injury. And the idea behind this tool was first, the patient would come in to the ED and they would present with their injury and they would get a spinal cord injury classification according to the American Spinal Injury Association, or ASIA. So they had an ASIA score of A, B, C, D, or E, A being the highest. So they might be incapacitated from the injury down, so from the spine down or from the neck down, and then E being the lightest. So the idea of the algorithm was to first read in all the information at admit and give a classification of the patient. So they had diagnosis, but we also had prognosis. So the same algorithm would try to predict at discharge what would be the AGES score of the patient. So right at admit, we would have an initial label of what AGES score the patient was coming in at, and then also a best estimate of what AGES score the patient would discharge at. And then so the clinician both had a sense of how to treat the patient in the current time, but also give messaging and also strategies and planning for how to give the patient PT, the right medications, the right amount of prescriptions and rest in order to have the best outcome 6 months, a year from now, when the patient was walking out of the hospital, whether they're going to walk on a wheelchair with crutches or as if they were never injured, as a very powerful and I think important thing to be able to support patients with that information as well.
So that was very interesting. So the spinal cord prediction and the classification algorithm that you were working on, was this with the UW Madison or someone else?
Yes, that's correct. That's with UW Madison. And that was published in eNeuro, so the American Neurological Society for the contributions to spinal cord injury.
Okay.
So thank you so much for sharing, some of your, past successes and past experiences. I think that was really, really insightful. Are there any challenges that you faced also in machine learning? I realize, that, a lot of people don't want to jump into this space because they feel like there's a very, really high, learning curve, and so they back off before they even start. And so do you have any ideas? First of all, what are some of the challenges that you faced as an individual? And now what would you do to encourage someone who is interested in jumping in, on how they could get started?
Mhm. So I can speak to different levels of this. First, there's someone as in a group or organization that might be interested in starting machine learning. And then there might be someone as an individual who's just interested in learning more about this as an end user, or maybe as a producer or creator of these types of tools. So first, speaking to someone being an organization, there's this idea that we call the data maturity curve. And essentially, every organization will exist on a spectrum, let's say 1 through 5, in terms of how comfortable they are with their data and how much they're leveraging it already. So let's say 3 is your typical organization that has business intelligence reporting, analytics, and they want to take the next step into data science. I would say an organization at that level can very naturally progress to data science. Now, let's say we have an organization at 2 or 1, they don't even have a standardized way of collecting, storing data, or they don't have the right infrastructure resources to develop applications or create data tools, then I would consider them using machine learning or artificial intelligence as jumping into it. And I'd actually recommend that they follow the typical process for data maturity, making sure that you understand your industry regulations around governing data, how to adopt data models and create entities out of the data that make sense, and be able to, before we even go to forecasting, just understand the state of your organization and derive value from the reporting that you're doing. So once we get to that average level of data maturity around 3, then I would say some of the more advanced problems like 4 and 5 is where we have issues such as supporting production machine learning models. So for example, model drift, or issues with feedback loop between multiple machine learning systems. Those would be typically more advanced problems that would come from organization. And then also around the use of these types of algorithms. So model governance, how do we manage the organizational risk of running these models? And then also how do we communicate with stakeholders and keep up to date, and also avoid red teaming things such as it's been the news, people might query ChatGPT to make bombs or guns. So being able to do the proper red teaming and handle ethical consideration as well. So I would say across the whole gambit of the data maturity curve, there is always a unique set of challenges, and it's really important to have the right team and the right roadmap for handling that. So that's why I would say data professionals are very much in demand organizations in these days, because everybody could use one. It's just a matter of getting your organization to the next level. Now, in terms of an individual, I would say First, as a end user, I think a lot of recent developments have done a great job of bringing this issue to the public consciousness, just understanding that if you're not paying for the product, then you are a product, so nothing is really free, and just understanding the use of cookies and how your PII is being used. And then also as an end user, I'd encourage you to maybe take a step further and explore some of certain types of algorithms. So let's say computer vision or NLP or discrete machine learning. How does that affect you? So in discrete machine learning, you might apply for a credit card or for a loan, and your information will get passed to the bank, and they'll go through an AI algorithm that will automatically reject or approve your loan. So that's how discrete machine learning may affect you. With computer vision, you might be driving around in the street, and the traffic camera will take a picture of your license plate, and your information will be within the traffic system, and no human ever has to look at it, but the government already knows who you are. So that's how computer vision might impact your life. And similarly with NLP, with ChatGPT, there's been a lot of popularization around chatbots interacting with people on the internet that aren't actually people, deep fakes. Those kinds of concerns, I think, are within NLP realm, what you might be interested in as an end consumer. And then finally, as a producer or creator of machine learning, artificial intelligence, I think just as there's a data maturity curve for organizations, there's a learning curve as an individual for becoming a data scientist or a machine learning engineer. And I think identifying your strengths and your interests and being honest with yourself, what you're good at and what you want to do is really important to having success in this domain. So there are a lot of different data professions. You can be a data engineer, a data scientist, analyst, you can be a software engineer, project manager, architect. You really need to sit down and think about what you want to do, what you're good at, and then from there, reach out with your network and find people who are already doing what you're interested in and get to that next level.
Thanks, Clark. There's really not a lot of opportunities for someone to get involved in the space. One topic I'm interested to kind of get your thoughts around, and maybe we can kind of keep it at more healthcare focused, is kind of where do you see AI models in healthcare kind of heading in the next 5 to 10 years? I know there's been some concern with doctors about AI potentially replacing some of what they do. I'm sure patients have some ethical concerns about, is a doctor really the one that's looking at my medical history and my medical results, or is it more of an AI? Just kind of get your thoughts around where you kind of think those things might be heading in the next 5-10 years or into the future.
I would say within the next 5-10 years, we still have a lot of differentiation within the healthcare industry. So we have some clinics and systems that are at the bleeding edge and driving not only healthcare AI innovation, but AI innovation for the entire domain of expertise. And then we have other clinics, it's a small percentage, but some of them are still on paper records and they haven't even undergone the digital transformation yet. So I imagine in the next 5 to 10 years, I think the digital transformation will become much more standardized and reach much deeper in terms of the American healthcare system. But I think there will continue to be, for example, undocumented populations or underserved populations that are not touched by the digital transformation. So I think there is ethical responsibility of these large healthcare organizations, the one that have the most resources, to come up with, and also government agencies that explicitly serve these populations, to come up with solutions for how to have healthcare access and equity and diversity and inclusion. I think those issues are very fundamental, and those early stage digital transformation, getting patients on patient records into centralized healthcare systems is still going to be with us in the next 5 to 10 years. I think it'll just be in a different format. So instead of your local hospital going on EHRs, it might just be this group of people that don't want to be documented or can't be legally documented and serving that population. Another area where I see healthcare going in the next 5 to 10 years is specific AI becoming more specific and good at what they do. And then also the emergence of general and generative AI. So that first domain is, I think, a lot of tools which we currently use, for example, like substance detection, claims processing, reading text and images. Those tools will get better, but there will always be that component where we need that human expertise, the trained radiologist, the trained doctor. to get a human AI combination that's better than any of the one tools working by themselves. And I think this will be a challenge in the sense that already we're seeing aspiring physicians, healthcare professionals, choosing their profession in medical school now based on what they think will be valuable in the future. So radiology being one of those areas which has seen a lot of AI do really well. If I were an aspiring healthcare professional, I might not choose radiology because then knowing after I come out with $300,000 of medical debt, I want to be able to find a job that's high paying. Well, if AI is going to do that job, I might go for surgery or something that is not so easily automated by AI. So I think there is some important messaging for higher ed professionals, healthcare educators to really keep this issue in mind and think about the future of the profession. But I think there is a future there because as we found for specific AI, there are algorithms where both the human plus the AI working together will be better than either working alone. And then finally, one thing that I think 10 to 20 years, anyone talking about this being seen as a bit of a crackpot is the idea of a general AI. So having AI algorithms that can solve problems that they weren't specifically trained for. So recently we had things like transfer learning, pre-trained models that did a bit of that, but it has really surged with the algorithms that work in what we call a few shot or low shot space. So this is where we have large models that are trained to handle a variety of information and structures, and they can perform well on a wide variety of tasks without specific training for that task. So large language models and also computer vision generative models being great examples of these types of large generative models. I think they will make their way into AI in the next 5 to 10 years, and that will be one of the more transformative areas of this space as well.
Excellent. Great to hear your thoughts. Yanu, any further questions you have for Clark?
I think he basically covered it. It was really great discussing with you on just sort of like the next phase of AI in healthcare. I definitely agree with you on the fact that generative AI or the ability for AI to create things that don't necessarily exist from what they know about what exists would be really, really, truly game changing, as we already see in the space of ChatGPT, and we see some of that happening with images and things of that nature. And so now thinking about it, I think Todd was mentioning from a healthcare standpoint, and how do you see generative AI being used, especially in the creation of synthetic data, to solve some of these medical issues?
Mm-hmm. So one thing that I think is really striking about ChatGPT and LLMs is that previously, when you had GPT-3, it could do 5th grade reading, math, and some basic essay writing. With GPT-4, it was able to get really top-level scores on the SAT, the GRE, and also the LSAT. And there's been some jokes about your lawyer is an AI. But I think as we advance into generative AI and LLMs in the next 5 to 10 years, there's a lot of memorization and general knowledge and context that goes into becoming a doctor and understanding the general context. I think LLMs can both boost the shortage in certain medical professions on the education side, and it can also boost shortages on the provision of care with being able to provide general context and making clinicians more efficient. This is within LLMs in particular, but there's also other domains that we haven't talked about, like telemedicine, remote surgery by robotic arms, and also developments in drugs and so on. LLMs, I think, is one area that, because of the current state and new developments, is very hot. I'd also encourage listeners, whether you're an end user or a creator, just to think about out-of-the-box solutions. And there are things that we're not talking about today, which I think will be in play in about 5 to 10 years as well.
Thank you, Clark. I definitely agree with what you're saying there about generative AI. I think it really helps to augment and improve efficiency for various workers. So I guess we'll just, as one final question, we'll give you like 1 more minute. Do you have any further things you want to discuss that you didn't get a chance to today, or any closing thoughts?
Mm-hmm. I think a closing thought is um, science and technology has always been hailed as something that has a lot of progress and drives society forward. I think healthcare technology in particular still has that very enlightenment and progressive view in terms of making the world a better place. And I think having this perspective is very valuable, and being able to be self-critical and understanding the shortcomings with this set of assumptions is important. But I definitely don't want to see healthcare lose this bent towards making the world better and improving conditions for society as a whole. So I think there are definitely a lot of broad societal forces pulling in different directions, and I'd encourage everyone being a healthcare practitioner or a user of healthcare just to think deeply about where you stand on many of the ethical issues, and just bring what you can and contribute to the space.
All right, thank you, Clark. Thank you. Thanks again for joining us. Really appreciate you taking the time and giving all these great insights to our audience.
Yeah, thank you for having me.
Yeah, thanks so much, Clark. We really appreciate you being on here. And so I want to thank our audience for joining us again today. We are looking forward to seeing you next time. Take care and bye.
This has been the AI Innovation Space, sponsored by Illumin. Thanks so much for listening.
Be sure to connect with us through LinkedIn and the Illumin website to learn more about how AI and emerging technology can help you. Also, be on the lookout for our next episode coming soon. Thank you so much for joining us. Have a wonderful day.